So we have seen two switches in parallel. So these are all the symbolical notations, right? So this denotes what? So if there is an element or if there is a thing P, so to negate it, what you use? What is this called actually? What are these calls? It's called
Logic gates.
logic gates, right? So it's called inverter gate or negation gate you can call, right? So whenever P, this will negate it. So the output will be not P. And here two things enter, P and Q enters. And so for R, we usually use this something like this. Here it is given something like this. Okay, anyway, for AND it will be blunt. I think these things, right? P and Q. So this is just an example. We are checking what is the output of this particular circuit, right? P is there. So here P goes and this is not Q and this is not R. So P and not Q, it is connected using what? This is AND symbol. So P and not Q. So P and not Q and not R, both are connected using R. So the output is P and not Q. So from here P and not Q comes and from here R comes, not R comes and both are connected using R symbol. So P and not Q are not R. So that is the output of this particular combinatorial circuit or logic circuit, whatever logic gates. Okay, here similarly. So similarly this is P and this is not R and these two are connected using R. So PR not R is the output from this particular sub-circuit, right? And then again one more is there. This part we have to see. This is, how do you check this? P becomes not P. So not P, then Q and not R, it is joined together using R. So QR not R. So from here not P, from here QR not R. Both are connected using again R. So not P, R, QR not R. So there are two outputs. One is this one, the other is this one. And both are connected using AND gate. Right? So can you find the output of question number that 40? Can you do that now?
Yes.
Take some 2 to 3 minutes you can take and then tell me. Slowly do it and then.
Ma'am, A is not P or not Q.
Which one, Pa?
A.
Not
A.
P or not Q. Check. Okay, it's very simple. Because P goes here, this is not P, and Q, and this is negated, so it becomes not Q. R symbol is there, so this is not P or not Q. Okay, Pa, good. Next, B part. B part, this is P first, and this is not P. This is Q. So not P and Q are connected using AND. So not P and Q. So not P and not P and not Q. Both are connected using R symbol. So what is the output here? Not P or not P and Q. So till here the output is this one. Again that is being negated here at the last. So not of this.
Ma'am, it's P
Ma'am, it will
or
be P, no?
Oh, it's only P, right? Sorry. Oh. Sorry, it's only P. Sorry. Okay, do 41. A part. So here P, here Q, here not R. So Q not R, Q R not R. So P, Q R not R connected using AND. So this becomes P and Q R not R. And again one not is used. So here not of P and Q R not. Okay, va? Hello?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. Sorry, you tell B part. Then we'll go to that.
Ma'am, not P and not Q, union P and R.
Not P and not Q, union
P
P
and
and.
R.
Okay, simple. Not needed. I think you know how to construct a combinatorial circuit and all. Okay. Tutorial session will do. I thought I'll complete more and then go for tutorial session. Okay. Duality law. So what do you mean by dual? See, there are two formula or even two statements, right? So two statements are said to be duals of each other if either one can be obtained from the other by replacing and by R and R by and. So usually the connectives R and are called the duals of each other. So there is one formula. So if you can obtain the other formula by replacing R by and by R, then it is called what? Dual of each other. Whenever you find a true, true should be replaced by false, false by true. That way. So can you give an example? See, that's what. See, if the formula A contains the special variables true or false, then A star, its dual is obtained by replacing true by false and false by true in the above following changes, right? Okay, so better I'll give you an example. I think, hope you can understand. For example, there is a formula P and Q. So what is the dual of this formula? P R Q. So there is a formula not P R Q and R. So what will be the dual of this? Not and all you should not change. So not P and Q R R. So both these two formulae, they are called duals of each other. Okay. So there is some advantage in finding the dual of a particular formula. See, even this, not only it is applicable for formula, even you can apply this for an equivalence also. See, for example, I'll take De Morgan's law. Not of PRQ not of PRQ, it is equivalent to not P and not Q. I think you know this, right? This is one De Morgan's law. Okay, what I'm saying is I'm going to take the dual of this particular formula, right? So what will be the dual of this formula? Not of P and Q is equivalent to not P or not Q. So what I'm doing, simply wherever I find R, I'm replacing by and wherever I find and, I'm replacing it by R. So these two are duals of each other. So one advantage is whenever you want to prove this, it is enough if you prove the equivalence of the dual of that particular formula. Clear? Suppose I want to prove this equivalence. This is one equivalence, right? So suppose if I want to prove this particular equivalence, you find the dual of this and try to prove this is an equivalence. That is, this is equivalent to this. If you try to prove, then it is same as saying this is equivalent to this. Clear? Hello? Hello?
Yes, ma'am.
Okay.
So one more thing, suppose there is a formula P. Actually, if it is equivalent to true, okay. Formula means it's not a single variable, yeah. Some formula P, maybe it may have a lengthy expression. I'm not writing. Just for an example, I'm saying there is a formula P. So maybe I'll call it as capital P. Because it has more than one variable, some lengthy formula is there, right? Okay, some expression is there. So, but that is logically equivalent to true. And it's a tautology, right? What I'm doing is, I'm finding the dual of this, calling that a P star. So, dual of that will be equivalent to what? If some formula is equivalent to true, the dual of that formula should be equivalent to
False.
false. So if you are finding tough, that is, if you are not able to prove this, that this formula is equivalent to true, you can find the dual of that formula and try to prove that that is equivalent to false. Both mean one and the same. If you are proving this, and finally you can conclude that the dual of this will be equal to this, hence I have proved the result. Okay. That way also you can conclude. You need not prove the original formula, original equivalence. You can prove the what dual of that particular equivalence. That way, indirectly, you are proving the original equivalence. That is applicable, right? 1 minute before going into all these things. See, prove the following.
Looks like
Enema? Yes.
you are saying like this expression is true, then duality of P is false. So it says like we are finding the negation of it, right, ma'am? So what's the difference between negation law and duality law?
Actually, you say that it is negation. Not necessary. Only for this particular case. It is not necessary that every time P should be is equivalent to true, right? Even P can be equivalent to some other Q. Your question is right. But every time P need not be a tautology, right? Suppose P is equal to some other formula Q. But I'm not trying to, but I'm not able to prove this. I can try to prove that P star is equivalent to Q star. Where Q star is the dual of Q and P star is the dual of P.
Okay,
so in this case, where negation comes. Clear? Got it? So everybody is getting her idea, what her question is valid. Others? Hello? Why are you all listening?
Yes, ma'am.
Yes, ma'am.
So
Yes,
here
ma'am.
I will have some quiz so that okay, can you take one question? We'll try without constructing the truth tables. We'll do later. Okay, prove the following equivalences by proving the equivalence of the dual. So take down the second one first. Easy one first we'll do. See? Without the
can you show the question?
I'll write. Okay, sorry. I'll write that, no problem. PRQ tends to R is equivalent to P tends to R and Q tends to R. PRQ. I asked you to prove all these things. You remember? I told you I'll ask you in the next class. Sure. We need to prove this here. PRQ tends to R is equivalent to P tends to R and Q tends to R. So instead of proving this, what I'll do is let this formula be some 1, right? Right? Find the dual of 1. Or I'll write the dual of 1 is. What is the dual of 1? P and Q tends to R. Correct?
Yes, ma'am.
Or something is missing. Can I write like this? Some problem. Better we write this formula completely in the R and that formula. It's missing, right? That is. What is this actually? This is looking like P tends to Q. How will you write here?
Not P or Q.
Simply, P tends to Q, no, not P or Q. So here P or Q tends to R. So it should be not of P or Q. R is equivalent to, and this is not P or R and not Q or R. This is the thing you need to do, right? Let this be 1. The dual of 1 is not of P and Q and R is equivalent to not P and R, and here and will become R, not Q and R. Okay, let it be true. To prove 2. Okay, how will you prove 2? Shall we take the left side or right side? Which one will take?
The left side.
Left side will take. Okay. Not of P and Q and R. Either you can use this symbol or this symbol here. Both okay, no problem. Sure. Expand this first. What law you will apply? Apply some law.
De Morgan's law.
De Morgan's. Not of P or not of Q and R. Now what law you will apply?
Distributive law.
Distributive. So if you apply distributive, what you'll be getting?
Not of P and R or not of Q and R.
Not P and R, then again R, not Q and R. So which is nothing but what? You got the second one, right? From 1 you got the second one. Hence, I hope you understand. See, we need to prove this statement here. So what I am doing, I am taking the left side. I started with the left side and arrived at the right side. That means I proved this statement 2. That means what? The dual of 1 I have proved is true. So whenever the dual of the statement is true, the statement is also true. Hence, 2 is true. That is, dual of 1 is true. So therefore, 1 is also true.
Ma'am,
Yes, tell me.
what law did we use in the end, ma'am? After De Morgan's?
What law? Distribute.
Okay, ma'am.
Distribute. Slowly you can write, please. Write it. I need to complete, I am planning to complete one more called normal forms. Maybe in the next class I'll complete. Then we'll have complete revision. More tutorials, 2 tutorial sessions we'll have. Then we'll go to inference theorem. If you have completed, you say, then we'll go to the next. First question will be.
Excuse me, ma'am.
Yes, ma'am.
Ma'am, the vice versa of the given statement is also true, right? Like, if the given statement is true, then the dual of that statement is also true, right?
Yes, yes. If one particular statement is true, statement in the sense what? Equivalence, not statement.
Yes, yes, ma'am. Sorry, equivalence.
Very, very important. Suppose there is one formula. If I am saying PRQ is true, it will not imply that P and Q is true. Please, everybody, please be careful. PRQ is a statement. P and Q is a statement. Both are duals of each other. They need not be true. Right? But one equivalence is true. No? The dual of that equivalence is also true. Everybody got it? Hello?
Yes, ma'am.
Okay. Can we do one more question? The first question. Not of not P and Q or not P and not Q or P and Q is equivalent to P. Not of not P and Q and not P and not Q. Okay. Sorry, this is equivalent to P. We need to prove this, right? Let this be 1. So instead of proving the given statement, what we'll do, we'll take the dual of this particular statement. So what is the dual of this particular statement? Or shall we apply De Morgan's law? First we'll change this and then go for dual. Better, huh? We'll apply not here, right? See, this is like A union B the whole dash. So what is A union B the whole dash? A dash. Okay, negation. Negation of A or B is negation A and negation B. So this part is over. Then RPN. Apply negation again. If you apply negation again, what happens? This becomes P R not Q and P R Q. Or P and Q is equivalent to P. This is the thing we need to prove. Check whether I am right. Somewhere I missed any R or and.
No, ma'am, correct.
Correct. Check. Okay. So the dual of 1 we have tried now. So the dual of 1 is, please, what should be the dual of 1? P and not Q or P and Q. Here again and P R Q is equivalent to P. This is dual of 1. We need to prove 2 now.
Ma'am?
Yes, Pa, tell me.
Ma'am, I have a doubt. Right before the statement, when we apply negation to the whole expression, will that or change to and change to or?
Yes, Pa, 1 minute. I'll write and show you. Not of A and B, then it becomes not A or not B. Similarly, not of A or B, then it becomes not A or will become and not B. Same De Morgan's law only. This is like A intersection B, the whole dash is A dash union B dash. And
yes,
A union B. Got it?
Yes, ma'am.
So we have to prove 2 now, right? How to prove 2? Take the left side, right? P and not Q or P and Q and PRQ. Sure, okay. Shall we combine this? Any idea? De Morgan's law use pannalama? Illa, sorry, distributive law shall we use? This is like A intersection B union A intersection C. So what is A intersection B union A intersection C? It is A intersection B union C, yeah?
Yes, ma'am.
Sorry, okay. See, it is like A intersection B union A intersection C. So it should be A intersection B union C. P and not Q are Q R and PRQ. So what is not Q or Q?
Q.
Not Q
It is
or
true.
Ma'am, true.
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 Something is true or something is not true. So if you use an R between that, it is always tautology. It's a tautology. This is always a tautology. So P, it is and true and PRQ. Okay, what is P and true?
P.
P. So what is P and PRQ? Which is bigger here? PRQ or P? Which is bigger?
P.
P. So the final answer will be P.
Ma'am,
So
this is
instead of
absorption at last.
what?
Ma'am, here in the last statement we have then applied absorption law.
Yes, absorption law. Very good. Correct. Good. Yes, absorption law. Correct. A intersection A union B is A, or A union A intersection B is also A. Correct. The third question, can you try by yourself? So that I'll ask somebody to share your screen after doing that. Third question. After completing this, you should tell me. I'll show you the third question.
Ma'am,
Yes, ma'am.
is it possible to explain the last step again?
Yes, of course, of course. This part, right? Here, from here, shall I explain?
Okay, ma'am.
See here. See, this is like A intersection B union A intersection C, because A is fixed here, right? So what is A intersection B union A intersection C? It is A intersection B union C. So I have identified what is A. A is P here, B is not Q here, C is Q here. So I am writing A intersection, that is P intersection B union C. What is not Q or Q? Any formula or its negation, if you use it, is always true. Tautology. So what is the meaning of not Q or Q? Either Q should happen or not Q should happen. It always happens, right? Either something should happen or something will not happen. Should not happen. So if you use an R between that, it is always a tautology. So this is always a tautology. That's the truth value is true. So P and true. That's what I am writing here. Then I am writing this as such. P and true, you have seen this already. What is P and true? It is like A intersection universal set. Some formula A intersection T is just universal set. Everything is there. So A intersection universal set is always what? A. So P and true is always what? P. So this becomes P simply and PRQ. So P and PRQ is nothing but P. Either you can say absorption law or symbolically you can write like this and check. A intersection A union B. Which is bigger here? A is bigger or A union B is bigger? A union B is bigger. So whenever you find the intersection of two sets, and if one is contained in the other, the intersection between them will be the smaller set. So A is always contained in A union B. Right? So A intersection A union B is always A. So the same logic here if you use P and PRQ is P. Clear, Pa?
Yes, ma'am.
Okay, I'll write the third question now. Please do that. Try. P and P biconditional Q and this tends to Q is always a tautology they want to prove. So you are not going to prove this statement directly. We are going to find the dual of this statement and prove the dual. That is our aim. So better you expand this, then go for the dual, right? So P and, hey, what is P biconditional Q?
And P implies Q and Q implies P.
Check. Correct. P implies Q and Q implies P. Okay. Many things are here, right? So P and this is not P or Q and not Q or P. The whole thing tends to Q is always a tautology. See again, can you see here something? This is some P, this bigger thing, this is some P tends to Q. What is P tends to Q again? Not of this RQ. This is a pattern. You have to prove this. Even you can apply negation inside. It is like A intersection B intersection C. 1 minute here. A intersection B intersection C. Negation of that, or I can call dash. It is nothing but A dash, that is not A, or B dash or C dash. Extended De Morgan's law. Or you can call union. The same here you have to apply now. A and this is your B and this is your C. This part is clear? You feel that I am going fast, you say, Yanma, tell me.
Ma'am, could you repeat the last step again, ma'am? I can't get.
Okay, no problem, no problem. See here, this is your A. This is your B. This is your C. It looks like A and instead of and I'll use intersection. Intersection B intersection C. The whole negation is there outside. Okay. This is called extended De Morgan's law, right? So if you apply not here, again not is applicable to each and every formula inside, but and will be replaced by R. Intersection will be replaced by union. Is this clear?
Yes, ma'am. Yes, ma'am. Now I got it, ma'am.
Now you got it. The same thing I'm going to do.
Excuse me, ma'am.
Yes, ma'am. Tell me.
Here, ma'am, B intersection C is in brackets, right? So can we take it as continuous?
Yes, ma'am, that's what.
Why?
And I think we can use associative law here.
You can use it. You can use it. It's not the bracket here. This entire thing is one thing. I'm not, see, only this is covered inside the bracket. Here, 1 minute. This entire thing is inside the bracket.
Ma'am, in the second step, if you see, In the second step, we have P and P. P gives Q and Q implies P, and that is inside the bracket.
Okay, no problem. See, that's what I'm treating this as one formula B, and this is one C. This is one A. No problem. If you see like this, it is A intersection B intersection C only, right?
Okay, ma'am. Okay, understood. Yes.
Got it. No confusion. Okay. Shall I proceed now? No confusion?
No, ma'am.
Cherima, now you apply. That is not A. So not B. And this and will become R. Then again not of this. Not of, not P or Q. And this and will become R. Not of, not Q or P. Then close this. RQ is equivalent to true. I think directly itself we can do.
Ma'am?
Ma'am,
in that B, it should be P and not Q. We are applying De Morgan's law, no, ma'am, here?
I didn't apply inside. I have to apply. That's why I put a bracket. Outside that is not right.
Yes, ma'am. Yes, ma'am.
I didn't apply. I am going to apply. So this is equivalent to not P or now you apply De Morgan's law. This becomes within brackets you write P and not Q and R. Here again Q and not P. Close this. RQ is equivalent to this is the thing we need to prove. Once you complete, you say, shall I move on to the next? Which I will proceed. Oh, I need one more. So what is the last line we are having? I'll write that once. We have to prove this. Let this be 1. So the dual of 1 is not P and P are not Q and Q are not P and Q is equivalent to false. We have to prove this. Okay. We'll say take the left side then.
Excuse me,
ma'am.
ma'am.
How to proceed?
Excuse me, ma'am.
Yes, Pa, tell me.
Ma'am, when we are taking the dual, the T will become false, right?
Yes, false. I'm sorry.
Yeah.
I thought I have written correctly. Correct. It should be false. Sure. Now how to proceed? I have taken the left side now. I am trying to prove that it is a contradiction. It's called contradiction. How to prove it? Shall we apply distributive law here?
Distributive law.
So not P and P. Again R. Not P and not Q. Then and Q are not P. So what is not P and P? False.
False.
False are not P and not Q, and Q are not P. False or anything?
It will give not P and not Q.
Q are not P. Okay, not P or Q. So any way of simplifying this?
Ma'am, we'll take the not. No, not.
Whenever we'll take the
No, ma'am, no.
any other simplified way of doing this?
Ma'am, we can take again distributive with Q.
We can write like this, right? Not P and not Q and not P. You can assume this as some A. Correct? Intersection B union C. Okay? That way it can be. Maybe if you see something easier, you can tell me. Okay, I'll write that again.
नहीं कर सकता, काम कर रहे टर्नओवर नाटक चेंज हो जाता है. नहीं तो काम कैसे करेगा आदमी? वहां गीला नहीं होता बाथरूम के साथ, कुछ नहीं होगा. अभी हम काम कर रहे हैं, हम नहीं घूम सकता. तुम 1010-15 मिनट लगाती हो. ठीक है, हम 2 मिनट देख रहे हैं.
Okay, the last line I'll repeat again. Not P and not Q and not P or Q and Q. Okay, this is the last one. Okay, no problem.
Ma'am, can we show the previous slide once, ma'am?
That's what, and the last slide only I'm writing again. The last line and repeating, that's all. So that we can expand it. The last line, this line I have repeated that.
Okay, ma'am. Okay.
Okay. Okay, now tell. As I told you, this is A intersection B union C. So what is A intersection B union C? A intersection B. B is not P. Union. A. Intersection. You're very horrible, yeah. Okay. Then. What will be this here? Can you observe and say it's easy only? Not P and not Q and not P. Again not P and not Q. Nothing. Okay. R. What is this one? Combine all these things. Not P and not Q and Q. False,
Ma'am,
Yes,
can
ma'am.
we not take distributive over that outer Q which is present
Yes,
outside?
ma'am. Outer Q, like A and B and doing with Q, so that the negation of Q and Q will get
this one.
reduced.
Okay, you are saying this one with this one, correct?
No, ma'am. This one, yes, ma'am. This outer Q.
This one and this one.
Yes, ma'am. Yes, ma'am.
Okay. So that way what will happen if you take A and suppose if I call this as D, it will become one false will come, right? Oh,
Yes.
there itself the problem will be solved, right? You need not expand further. Check. Correct. Yes, correct. Thank you. So can every others understand what is the problem? No.
Yes, ma'am.
No. So what should I do? Not P and not Q. And Q. Since everything is connected using AND, right? You need not use any other lock here. Very simple. So I'll erase all the top things so that it will be easy. This is A, this is B, this is D. This is A, this is some B, this is some C. So A intersection B intersection C. So I'm just rearranging. First I'm writing A intersection C, then intersection this one. So if you combine this becomes not P and not Q and Q and not P or Q. So this is false and something. It is always false. So the negation part we have to. You may wonder why should you all do such a lengthy procedure. Sometimes this will be helpful. Not every time proving the dual is easy compared with the original one. Right? Just we are learning the process. So sometimes doing the dual, proving the dual is easier rather proving the given state. Okay, if you want, you can look into this from the beginning.
Ma'am, can you show the last slide once?
Last slide, sure.
Ma'am?
Yes, ma'am.
Since dual is false, that means the original equivalence was also false.
No. Equivalence, since, see, one, I'll go back. See, this is the original statement here, right? Original statement is equivalent to true. So that means the dual is false. 1 minute, one good example I'll give you. I think you'll be better convinced. See, P or not P. What is this equivalent to? True, Madam? Hello?
Yes, ma'am.
So what will be the dual of this? P and not P, what it should be equivalent to? Of course, we know very well it is false. Clear?
Yes, ma'am.
Okay, I'll stop here. I think time is over. What's the time now?
42.
42. I'm sorry, I've taken much 2 to 3 minutes extra.